Hello, today we're going to talk about conditional probability and tables of data. Okay, so where we're going into here is we're going to look at a conditional probability formula and two kind of big dedicated examples. All right, first up, when you read this expression P/A, okay, this slashy thing here, symbol, is going to stand for given that when you read it. Okay, well, given that, what do you mean? Probability of B given that A already occurred. So you can think of it as event B occurs after event A already occurred. Okay, and then when that's the situation, we can go through and we can follow our formula. Okay, so A has already occurred. The probability of whatever's already occurred, you'll notice, is in the denominator, and it has to be in that order or you get some kind of crazy answers. Okay, so let's go through here. I have a first little table set up for us to do an example here. So it says, this is some data about driving in the snow test. Okay, you either have a class or no class, and you either pass or fail, and I've already indicated the totals for each section. So let's do number 1A. Find the probability the person passes the class given that they take a class. Okay, so we want to do probability of class and pass divided by the probability of class. Okay, so again, follow what happens second and where it fits in here. Okay, all right, so from the chart, class and pass. So class and pass is 30, and we're going to use this grand total in the corner as our denominator. So we're going to have 30 out of 160 divided by probability that they took a class. So the total here for taking a class is going to be 80 over 160. Okay, so somewhere in a previous video I talked to you about if you have a fraction like this, and I'll do this one, divide by 80 over 160. Dividing fractions means you multiply by the reciprocal, and then what conveniently happens is that these two denominators will cross-reduce, and you end up with 30 over 80, or 3/8. Okay, so back here at my original spot, if I cross-reduce the denominators, you can see 30 over 80, and that in fact reduces to 3/8, and there's your answer. Okay, let's try part B. Probability of failing given that fails given that they take no class. Okay, so probability of no class and fails divide by probability no class. All right, so on top we need to go to where it says no class and fail. So I see here 60 over 160, and then probability of no class, so we need this total here, 80 over 160. And then we'll solve. So we can reduce the 160, so we've got 60 over 80, and that will in fact reduce to 3/4. Final answer. Okay. All right, next up we have probability of fail and class divide by fail. All right, so both class and fail, 50 out of 160. On the bottom, probability of fail, 110 over 160. Reducing again the 160s, we have 50 over 110, which is 5/11, and that's your final answer. All right, one more for here. Probability of fail and no class divide by probability of fail. Okay, so we have fail and no class. Fail and no class, there it is, 60 over 160. Did I put the same one class? Oh, what did I do? Something happened. Oh, that's right. Divide by probability of fail. My bad, I looked over to the left. Probability of fail looks like 110. So here, 110 over 160. 60 over 110, so 6/11. There we go. Ooh, guess I've done too much math today. All right, so there's one round of examples. I have a second one here, and I'm going to go through and set these up. If that's enough for you, you're welcome to leave the video, and if not, you're welcome to stick here with me. Okay, so in red, I just want to round there the chart and fill it in the totals before you arrive, just to keep us moving here. All right, so question A, we're going to do A in 1996 divide by A. Okay, and these are probabilities. I'm just shortening it up just a bit. All right, so we got to go to A in 1996, and I see 400 over the 2504. Divide by A, so we need the total of the A, 1595 over 2504. We'll reduce the 2504s. You get 400 over 1595. And actually, if you throw that in the calculator, it'll reduce that for you. 80 over 319 is where I landed with that one. All right, B, we're going to do D in 2016 divide by D. All right, so got to go find D in 2016. Okay, so I'm in here. It looks to me to be a 45 over the grand total in the corner, that 2504 number, divide by total of D. So we got 90 over 2504. The 2504s cancel, so we have 45 over 90, which in fact is 1/2. And that's your final answer for the probability. All right, keep going here. We got B in 2000 divide by B. All right, so on top, B and 2000, 250 over 2504. Total B's 655, 2504. The 2504s cancel. So we got 250 over 655, and actually that reduces to 50 over 131. All right, I got two more here. So we could do 2000 and C divide by 2000. All right, 2000 and C. So it looks like 60. I'm going to go this direction here. Over the corner, total 2504 divided by the sum of the 2000 is 935 over 2504. Cross reduce 60 over 935, and it's nice and reduces to 12 over 187. And that's your conditional probability. Alrighty, one left. So we got 2016 in A divide by 2016. All right, so let's see if I can just go cut to the chase here. 2016 in A, 605, divided by the 2016 total, 1009. And there we go. We didn't have to write all the denominators down. Okay. So again, these are just some examples going from data in a table and using our conditional probability formula. I hope something here was helpful in seeing the pattern to work through these complex fractions. And I wish you the best of luck with that. See you soon.